The best way to explain equivocation is with an example. Imagine that we are in a war situation and the enemy has sent a message from its headquarters to the troops. It's encrypted. We caught the encrypted message, the ciphertext, and we are now hammering it in our computers, trying to find out what could possibly be the message that the enemy has sent. So we work and work, and finally we find a key that if we apply the key to the ciphertext, it extracts the plaintext, and the plaintext read, "We shall attack after 3 p.m. tomorrow." Well, this is valuable information. We know what are the plans of our enemy. We cracked his cipher. Hooray. But suppose that a diligent fellow there in the crypto office keeps hammering on the ciphertext, massaging it and manipulating it and trying to see what else is there. And then he finds that there is another key. And the other key said, "We shall attack before 3 p.m. tomorrow." That's the other plaintext. Wow. And he keeps working and working and working. Finally, he gets a third key that says, "We shall not attack at all. We shall remain in defensive postures." So what do we have here? We have a ciphertext that when we milked it dry, when we hammered it to the bone, we extracted 3 keys from it. One key says we should attack after 3 o'clock, the other key says we should attack before 3 o'clock, and the third key says we should not attack at all. Where does it leave us? Equivocated. Because we have 3 keys, they are equivalent from a cryptographic standpoint. Each of those keys is associated with a different plaintext, and we don't know which of those 3 possible messages that the enemy could have sent was actually sent. Now, the enemy units, they know which of the 3 messages was actually sent. But we use cryptography, we are at an impasse. Because altogether, those 3 messages give us 0 information, because they say the enemy will either attack or not attack, and if the enemy will attack, they will either attack before 3 o'clock or attack after 3 o'clock. So we know nothing. Sometimes all the messages together give you something, but the principle is simple. Equivocation cryptography is cryptography that is based on using a system such that when the enemy catches the ciphertext, and even if the enemy is very powerful and very smart and has the fastest computers in the world, they end up with an impasse with 2 or more messages that each of them could have been the one but we don't know which. Equivocation can be just based on 2 messages, or it can be 3, or it can be an infinite number of messages. But the principle is the same. And it is very important to distinguish cryptography based on equivocation from cryptography based on intractability. Intractability erodes, equivocation endures.